An investigation on geopolymer concrete with GGBFS and fly ash. Abstract: the conventional concrete used for the construction of large structures releases greenhouse gases leading to ozone layer depletion and global warming. An alternative solution to conventional concrete has been sought by many researchers. Geopolymer concrete is the one in which cement in conventional concrete is replaced by mineral admixtures such as fly ash, GGBFS, metakaolin, micro-silica etc. and chemical solutions acting together as a binder. In this paper, geopolymer concrete is made using ground granulated blast furnace slag, GGBFS, and fly ash in alkaline solutions, sodium silicate and sodium hydroxide, is compared with conventional concrete. The strength parameters investigated are, I. 7 days compressive strength, 2. 28 days compressive strength, 3. 28 days split tensile strength, 4. 28 days flexural strength. Workability and cost analysis of different cases of geopolymer concrete is also investigated. Keywords: geopolymer concrete, micro-silica, ground granulated blast furnace slag, fly ash, alkaline solution. Introduction. The climatic change owing to global warming is a grave environmental dilemma having significant pessimistic impacts on all living beings of the world. The discharges of greenhouse gases such as CO2, methane, nitrous oxide, chlorofluorocarbons, hydrofluorocarbons, etc. from diverse sources into the atmosphere are accountable for this critical impasse. One such cause of the release of primary greenhouse gas CO2 is the present production process for ordinary Portland cement, OPC. It was revealed that the world production of OPC had contributed almost 57% of the total CO2 emission into the ambience. Estimation is assessed that the production of 1 ton of OPC is answerable to the almost equal quantity of discharge of CO2 into the atmosphere. For the year 2014, the global utilization of OPC in the world was 3.7 billion metric tons. Likewise, 1 ton of cement production releases 1 ton of carbon dioxide into the atmosphere and consumes almost 4 GJ of energy. This is a severe hazard to humanity across the world. Therefore, research efforts towards the search for eco-friendlier materials for construction are going on too. The present production process of OPC is not merely high temperature and highly energy intensive, for which it needs to swallow restricted natural coal resources for calcination of limestone, but also a solemn threat to the environment. Hence, it is also a need of the hour to search for an alternative of conventional OPC concrete which should be user and eco-friendly and can be developed by conserving natural resources at low temperature and a cost of merely slim energy and, of course, cost-effective. Moreover, the conventional fine and coarse ingredients of OPC concrete are also mined from limited natural resources, hence the researches are essential for a type of concrete that can be developed by incorporating natural and industrial wastes to lower down environmental concerns. Geopolymer is a novel inorganic binder produced by the polymerization reaction between source materials, having higher silica and alumina content, of geological origin and alkaline solution in highly alkaline conditions at low temperatures and atmospheric pressure. Geopolymer concrete demonstrates excellent properties of resistance against sulfate, chloride, and acid attacks. In comparison with regular Portland cement concrete, it has strong prospective applications in the encapsulation of toxic solid waste and heavy metals. It functions as fire-resistant as it shows excellent high-temperature stability. Polymerization. Polymerization is a procedure of responding monomer particles together in a substance response to shape polymer chains or three-dimensional systems. In substance mixes, polymerization happens through an assortment of response instruments that change in multifaceted nature because of practical gatherings introduced in responding compounds and their inalienable steric impacts. Polymerization, any procedure in which generally little particles, called monomers, consolidate chemically to deliver a vast chain-like or system atom, called a polymer. As a rule, no less than 100 monomer atoms must be consolidated to make an item that has certain remarkable physical properties, for example, versatility, high rigidity, or the capacity to frame filaments that separate polymers from substances made out of littler and easier particles. Frequently, a large number of monomer units are joined in a single molecule of a polymer. Aim and scope. The project aims to find a replacement for cement, as cement manufacturing is one of the major contributors to air pollution. Cement industries release greenhouse gases into the atmosphere, which causes global warming and other environmental problems. Industrial dust like fly ash, metakaolin, microsilica, and GGBFS can be used to replace cement in concrete. This reduces the harmful industrial solid waste released into the environment and promotes sustainable development. The project helps to find out the constructions for which concrete can be replaced by geopolymer concrete depending on the workability and cost. Fly ash. Materials. Response: since need enough initiations potential. In this way, it's constantly utilized without withstanding sodium hydroxide to improve the alkalinity quality of examples. Along these, fly ash is produced from the combustion of coal in electric utility or industrial boilers. There are 4 basic types of coal-fired boilers: pulverized coal, PC, stoker-fired or traveling grate, cyclone, and fluidized bed combustion, FBC, boilers. The PC boiler is the most widely used, especially for large electric generating units. The other boilers are more common at industrial or cogeneration facilities. Fly ashes produced by FBC boilers are not considered in this document. Fly ash is captured from the flue gases using electrostatic precipitators, ESP, or in filter fabric collectors, commonly referred to as bahuzas. The physical and chemical characteristics of fly ash vary among combustion methods, coal sources, and particle shape. 4. Ground granulated blast furnace slag. Granulated blast furnace slag is obtained by rapidly chilling, quenching, the molten ash from the furnace with the help of water. During this process, the slag gets fragmented and transformed into amorphous granules, glass, meeting the requirement of IS 12089:1987, manufacturing specification for granulated slag used in Portland slag cement. The granulated slag is ground to desired fineness for producing GGBFS. It ensures higher durability of the structure and reduces the temperature rise and helps to avoid early-age thermal cracking and also improve workability. It is off-white and substantially lighter than Portland cement. Resultantly, it helps soften the visual impact of large structures such as bridges and retaining walls. 3. Sodium hydroxide. The most widely recognized soluble base activator utilized in the geopolymer concrete is NaOH. As an activator, NaOH isn't that dynamic that as KOH particle. In any case, the particle of NaOH are small in size and accordingly, they can infiltrate inside the system with a simple exertion. Likewise, NaOH particles have a thickness of extremely high charge which offers extra zeolitic development vitality. The properties of the resultant glue F geopolymer concrete are liable to the centralization of NaOH arrangement. While framing folio high concentration of NaOH may help in synthetic disintegration, however it opposes the development of ettringite and CH, carbon-hydrogen, bond. It has likewise been concentrated by the analysts that the high convergence of NaOH may give higher quality at early ages. However, for the matured examples it was discovered that the solid had poor morphology and non-consistency because of exorbitant O particles. One of the upsides of utilizing NaOH as an activator is that the resultant geopolymer concrete is increasingly crystalline and along these lines has more prominent soundness in unforgiving situations, for example, impervious to sulfates and acids. Sodium silicate. The point when at a high temperature of about 1100 degrees C or more, sand is melded with sodium carbonate, then sodium silicate is shaped. A result of the above response is broken up with the high weight steam and semi-thick fluid is framed, which are known as the water glass. The sodium silicate in its physical state can be found beneath. A sodium silicate/water glass alone can't be utilized as an activator to start pozzolanic lines. NaOH and Na2SiO3 are the most regular salt activator utilized in the geopolymer solid creation. Financially, sodium silicates can be found in various evaluations and states, for example, powder structures/fluid structures. However, fluid structure has progressively propensities to start response. It is found from the overview that Na2SiO3 having SiO2 to Na2O mass proportion of 2.0 blended with NaOH activator 24 hours preceding use offers better outcomes. Specific gravity. Specific gravity is the ratio of the weight of the volume of any material to the weight of the water of the same volume at a certain temperature. Specific gravity is a value to calculate whether a material will sink or float in water. Each material has some specific gravity. Specific gravity is calculated to know the behavior of the material, and it usually ranges from 0.1 to. Mix design. Mix design for conventional concrete. The mix design of the geopolymer concrete is done in an entirely different manner compared to that of conventional concrete. In this project, the mix design of the geopolymer concrete is prepared. Materials replacing cement. Quantity and fineness of material used to replace cement like fly ash, GGBFS and microsilica plays an important role in the activation process of geopolymer. It was already pointed out that the strength of geopolymer concrete increases with an increase in the quantity and fineness of the material. Similarly, higher fineness shows higher workability and strength with an early duration of heating in the case of fly ash. So, the main emphasis is given on the quantity and fineness of fly ash in the development of the mix proportioning procedure of geopolymer concrete. 6. Alkaline activators. In the project, sodium-based alkaline activators are used. The combination of sodium hydroxide and sodium silicate solutions are used for the activation of geopolymer concrete. It is observed that the compressive strength of geopolymer concrete increases with an increase in the concentration of sodium hydroxide solution and/or sodium silicate solution with increased viscosity of the fresh mix. An increase in the concentration of sodium hydroxide solution in terms of molarity, m, makes the concrete more brittle with increased compressive strength. Secondly, the cost of sodium hydroxide solid is high and preparation is very caustic. Similarly, to achieve the desired degree of workability, extra water is required, which ultimately reduce the concentration of sodium hydroxide solution. So, the concentration of sodium hydroxide was maintained at 10 m while the concentration of sodium silicate solution, 10 m, contains Na2O of 16.37%, SiO2 of 34.35% and H2O of 49.72. Water comes out from the mix during the polymerization process. The role of water in the geopolymer mix is to make workable concrete in a plastic state and do not contribute towards the strength in the hardened state. Similarly, the demand for water increases with an increase in the fineness of source material for the same degree of workability. So, the minimum quantity of water required to achieve the desired workability is selected based on the degree of workability, fineness of source material and grading of fine aggregate. Aggregates are inert mineral materials used as filler in concrete which occupies 7,085% volume. So, in the preparation of geopolymer concrete, fine and coarse aggregates are mixed in such a way that it gives the least voids in the concrete mass. This was done by grading fine aggregate and selecting a suitable fine to total aggregate ratio. The workability of geopolymer concrete is also affected by the grading of fine aggregate similar to cement concrete. Water to geopolymer binder ratio. Water to geopolymer binder ratio, the ratio of total water, i.e. water present in solution and extra water if required, to the material involved in the polymerization process, i.e. fly ash and sodium silicate and sodium hydroxide solutions, plays an important role in the activation process. Solution to fly ash ratio, as solution, i.e. sodium silicate and sodium hydroxide, to fly ash ratio increases, strength is also increased. But the rate of gain of strength is not much. significant beyond a solution to fly ash ratio of 0.35. Similarly, the mix was more and more viscous with higher ratios and unit cost also increases. So, in the present mix design method, the solution to fly ash ratio was maintained at 0.35. Preparation of geopolymer concrete mixes. The preparation of geopolymer concrete is similar to that of cement concrete. Two types of coarse aggregates 12 mm and 20 mm, fine sand, and source material, fly ash, GGBFS, micro-silica, were mixed in the dry state. Then add prepared mixture solution of sodium hydroxide and sodium silicate along with extra water based on water to geopolymer binder ratio and mix thoroughly for 34 minutes to give a homogeneous mix. 6 concrete cubes of side 150 mm, 2 cylinders of 300 mm height and 150 mm diameter and 1 beam of 100 mm x 100 mm x 500 mm are cast in 3 layers for each case. Each layer is well compacted by a tamping rod of diameter 12 mm. After compaction of concrete, the top surface was leveled by using a trowel. After 24h of casting, all cubes were unmolded and then placed at room temperature for curing. Fly ash geopolymer concrete is kept in an oven for thermal curing, heating, at 60 C. To avoid the sudden variation in temperature, the concrete cubes were allowed to cool down up to room temperature in an oven. 6. Experimentation. Workability. The slump test is carried out to determine the workability of concrete where the nominal maximum size of the aggregate does not exceed 38 mm. This test is used at construction sites all over the world. It gives the idea of the water-cement ratio to be used for different works. Fresh unsupported concrete flows to the sides and the sinking in height takes place. The vertical settlement is known as a slump and is measured when supporting mold is removed. Concrete is said to be workable if it can be easily mixed, compacted, and easily finished. 7. Cost analysis. Cost analysis is a summary of all the costs involved in doing particular work or unit work. In this project, Case 1, conventional concrete, Case 2, 100% fly ash, and Case 3, 100% GGBFS, are cast. The mix design for M30 geopolymer concrete was derived and obtained a mix ratio of 1:1.3:3.1. NaOH solution, 10 m, and Na2SiO3 solution, 50.32%, are required in Case 2 and Case 3 for the polymerization reaction. Quantities of the materials required for 1 cubic meter in all the cases and their rates are required for the cost analysis. Cost of cement, fine aggregate and coarse aggregate, 12 mm and 20 mm, are obtained from the Schedule of Rates 2012, Volume 15. The rates of the materials like NaOH, Na2SiO3, GGBFS and fly ash etc. are obtained from the commercial market value. Conclusion and scope for future works. The concrete specimens were prepared in the ratio 1:1.3:3.1 for 7 and 28 days compressive strength, 28 days split tensile strength and 28 days flexural tensile strength. Cement was replaced by fly ash and GGBFS in the second and third case, respectively, and NaOH/Na2SiO3 solutions were used for polymerization in the geopolymer concrete. The highest strength was obtained for 100% GGBFS geopolymer concrete. This shows considerably high strength compared to the 100% fly ash geopolymer concrete and normal cement concrete. The specific gravity of GGBFS and fly ash were found using a specific gravity bottle. The specific gravity of fly ash and GGBFS were found to be 2.45 and 2.92 respectively. Workability of all 3 cases was found using slump test and the slump value was obtained between 25-75 mm. That gives medium workability suitable for RCC work with less reinforcement. Cost analysis was carried out for all the cases and the highest cost was obtained for conventional concrete and the lowest cost was for fly ash based geopolymer concrete. This also shows that GGBFS-based geopolymer concrete is economical as well as gives high strength to be used in various construction works. The study shows that usage of GGBFS increases the strength of geopolymer concrete, and this reduces the harmful industrial solid waste released into the environment and promotes sustainable development. GGBFS can be collected from various industries and can be taken to a concrete mix plant or for making ready-mix concrete, which promotes a sustainable infrastructure in the country. Similar studies can be conducted on other aluminosilicates such as rice husk ash, metakaolin, etc. The durability of different cases of geopolymer concrete can also be studied to find out where it can be used. GPC roads, runways, pavement blocks, LTGS bricks, precast industries, automotive applications, and aircraft interior and cabin interior applications can be constructed or manufactured or fabricated in the future based on various investigations.